Okay, hi. So we are finishing up our 6.5 notes today. The only thing we're talking about is this idea of annuity. We're again talking about financial math. This is another application of geometric now series instead of sequences. This is going to wrap up our part of this chapter that's about sequences and series. So after this lesson, we're done with everything new that we're going to learn about sequences and series, and then we're going to wrap up this chapter by talking about Voronoi diagrams. Annuity. The only difference between annuity and regular compounding interest or simple interest, the only difference between those interest problems and annuity is instead of just putting a lump sum in at one point and then finding your interest rate or including your interest rate over a certain amount of years, annuities are when you add in to a bank account. Annuities are when you add into a bank account every year, right? We don't normally just have 13,000 euros sitting around that we're going to go put in a bank and just let it sit there. That'd be like for some of us, all of our money, right? And so what you normally do is you're like, well, okay, every year I can save 1,000 euro and put it in a bank and then let it sit there. So that's what annuity is. For the purpose of this, if you were to Google what is annuity, which I did, I tried to find a video that showed you guys that was more interesting than just my voice, again, telling you about this concept. And it's all just banks trying to tell you what an annuity is. And so what the real world is in terms of annuity, a lot of the applications of it is you give a lump sum to a bank or an insurance company, and what they agree to is that they will let it build on a certain fixed interest rate, saying like, we will guarantee you this percentage for your interest rate, and then when you retire, we will give you back your money in these segments, right? They're not gonna just give you back all of the money at once. They're gonna say, okay, when you decide to retire, which you'll be 60 something, maybe 70 something when you retire, then the insurance company will give you back the money that you gave them in chunks, in segments. But since you let them hold on to your money for a certain amount of time, they have given you an interest rate, which means that they've kind of rewarded you with more money by letting them hold your money. And so that's what the real world application of annuity is. This classroom application is kind of the same idea. Instead of giving a lump sum to a bank, we're putting installments into a bank. It tends to also go along with amortization, which we're going to talk about. I actually don't know how to say that. I've only ever seen it written, but that's how I say it in my head. And that's when you get a loan from somebody, talking about school loans. If you're thinking about going to school in the States, almost everybody needs to have a loan because university is very expensive there. So you need to get a loan and then you pay it back in a certain amount of fixed payments. And that's amortization. And you're still paying interest, right? So if you decide to pay it quicker, you don't pay as much interest for them to loan you money. So that's kind of what today is going to be about. So the reason why there's a difference when you put in 1,000 euro every 10 years and it's gaining interest for that amount of time, and then you want to figure out what's in the account after 10 years. The difference between this problem and the previous problems on your calculator is not a lot, but in terms of what we're calculating for the interest, it's very different because you've got 10 years. Let's just real quickly, we've got 10 years. So at the end, in 1 year, you've put in 1,000. And at the end of 10 years, you will have earned 10 years of interest on that, right? So you can plug it into the formula. You will have earned, if I were to plug it into my calculator for my financial solver, at a 6% interest rate, which is what this guy is, on that $1,000, now it's become 1,790.85. But the next year, you will have put in another 1,000. But if you're talking about 10 years later from your first payment, this payment is not earning 10 years of interest. It's only earning 9 years of interest because you've already spent one of those total of 10 years only paying 1,000. So then this next $1,000 is, or euros or whatever it is for this problem, is only going to earn 9 years worth of interest. And so then that $1,000 at the end of that total 10 years is worth 1,689.48. And then your third year, you plug in another $1,000 or euro, and that's not earning 10 years. You've already passed 2 years worth of it earning interest, and now you only have 8 years left of it to be able to sit in the bank and have interest. So then I could go up. I'm just changing my numerical solve guy. I'm going up and changing the n to 8. Going down to future value and pressing enter again, and then it becomes 1,593.85. And it goes on. So that's the idea here, is that since you're not putting in one big lump sum where it just sits there and gains interest over time, you're putting in money every single year. The first year is going to get the full 10 years worth of interest, but the next year it's only going to get 9 years worth of interest. And you go to the very final year and you've put in 1,000 at the end of that 10th year, but that 1,000 euro or dollars, euro, has not earned any interest. So it's just sitting there as 1,000, not having earned any money on it. So that's the difference with annuity versus all of your other interest problems that you've earned. And this is the more logical, reasonable, normal thing that people do. People don't normally put in 10,000 euro into a bank account and then just let it sit for 10 years. They probably put it in installments over 10 years. So the only way that it changes is, instead of putting 1,000 in for your present value, now that's 0. Now your present value is 0. Your starting amount in the bank, your starting amount was 0. Now below it, you will see something called PMT. And in that, you're going to put negative 1,000. So you should go, and that's just PMT stands for payments. So I'm going to change present value to 0. I'm going to change payment to negative 1,000, and then go up to 10, and then change my interest rate is still 6. All I need to go now down to is future value. And now it'll tell me how much is in the account after 10 years, talking about payments of 1,000 every year as opposed to a lump sum. And that's 13,180 euro 0.79. So the difference in calculation, the difference in your calculator, is just where you put in the number. Instead of present value, you put it in for PMT, which is payment. And that's the only difference with calculating annuity versus your other guys. The idea is because your 1,000 euro will not earn the same amount of years worth of interest because you're putting it in years later. Okay, that's it. Example 8. In order to save enough money for her college education, because this is a very common application of this, Sophia's parents set up an annuity where they deposit 100 euros at the end of every month in an account that pays 6% annual interest. They started this the year she was born. How much money will be in the account on her 18th birthday? Okay, so this is, we've got, let's go in and talk about what we put in where into your financial solver. You should be using your financial solver for this. Your textbook gives you a formula, but your formula packet does not give you a formula. The textbook, and from what I've read, it seems like the IB does not care. It will not give you method points for showing a formula for this, because they don't want you to memorize a formula. They want you to know how to use your calculator to solve this. So in this, you would, to get your method points, you would say maybe used my calculator, something. And then they would give you method points for using Financial Solver. Okay, so you should be familiar with using Financial Solver on this guy. Please don't try and use the formula. I'm not even going to tell you the formula, even though it's in your textbook. Okay, so N, we're going to leave blank for now. I is your interest rate, and that is 6%. We are staying consistent with that. Present value is your initial value that was in the account, and starting the account, there was no money in the account. And then your payments are going to be 100 every month. Future value, we don't know what that is. And then PPY and CPY, those are compoundings, and it doesn't tell us how many times it's compounded. It says 6% annual interest, but that doesn't really mean how many times it's been compounded. So if it doesn't tell you how many times it's been compounded, we're assuming it's compounding every time they make a payment. And that is something that your textbook says. That's something that the IB says, that if it doesn't tell you how many times it's compounding, but they're paying a certain amount of times a year, it's compounding every time you make that payment. So since we're paying monthly, that means it's compounding monthly. So your P/Y or your PPY and then your CPY should both be 12. Now, your N needs to be the number of years times the number of payments that you are making, which is 12. So you can even go in and type in 18 times 12 into your Financial Solver. You don't even have to calculate that outside of your calculator, and then it'll calculate it for you. Then go down to your future value and press enter. Oh, that's why. There we go. So your future value on her 18th birthday is €38,735.32. Monthly payments of €100 for 18 years on 6% annual interest at the end of her 18th birthday is $38,735, which is quite a lot.